thank you everyone for being here. Today we're meeting for the 12th Tech Talk. We started last year in January, and we had a break in Christmas, so that's why we're starting now this year with Tech Talk number 12. My name is Maria, in case anyone of you is joining for the first time, and I usually moderate these Tech Talks. As you have seen, the Tech Talk is going to be recorded, and we upload the video on YouTube afterwards so that people can watch it if they cannot join today. So just be aware of that. And with this, we can start. We have the same agenda that we usually have. First, we have a Tech Talk of around 20-25 minutes, followed by a discussion. In case any one of you is today here for the first time, we have very different topics. Usually we talk about open source technologies that have somehow a potential to improve digital sovereignty or to improve the functionality of cloud infrastructures that work with open source. And today is also going to be the case. And afterwards, we have a section where we will present some events and some news that we have from our side. And any one of you can add any other news or any other events that you think might be interesting for the community. So that's the agenda. And I would like to present now the topic of today's Tech Talk and our speaker. So today's Tech Talk will be about a tool that is used for managing multi-cloud resources and applications, and it's going to be presented by Christian Weiss from Daiteap. So just a few words about Christian, and then I can hand it over to you. He has a master from the University of Heidelberg and a PhD from the University of Bonn. He has a few years of experience in IT and telco in different positions, and is also the co-founder of Daiteap. And he's active in multiple European digital sovereignty initiatives, which is, of course, a great match for Alaska. So with this, I stop my introduction, and then I will hand the stage over to you, Christian, and you can start whenever you're ready.
Yeah, for the introduction. Good morning, everyone. So we are happy to have this chance today to introduce a bit an open source project that we did, more or less 2 years ago. And this project came out of some other project where we, let's say, were faced with the management of multi-cloud resources. And therefore, we saw there is a big demand from teams, but also from businesses to use, let's say, a kind of multi-cloud management approach. Because, as you know, currently, let's say, companies, enterprises, they are usually not focusing on the one cloud approach, but to avoid also the lock-in effects, usually they distribute their cloud initiatives on different providers. And from this, let's say, experience that we had, and also from the development, we decided to open source it and to give it also to the community in order maybe there is some, let's say, value or some interest in different approaches, technologies that we did, and can be then used for your own development. And hopefully, let's say, it brings you the benefit that you're expecting. So I share my screen, Maria, is it? Or yeah,
yes, share your screen.
Okay, so today I'm talking about open source multi-cloud console for resource and application management. Yeah, and we are Daiteap 𝗔𝗯𝗃-𝘂𝘁, founded in 2021. We have an office in Heidelberg. Our developers have more than 10 years plus experience in enterprise development, and we are doing software development around Kubernetes, blockchain, big data engineering, DevOps, and many more things. Yeah. So purely, let's say, code focused. And you can find the open source project on GitHub. Yeah, as I said, this is coming out from another project where we saw a big demand of multi-provider resource management. And I think there is a good installation guide that you can use and run it locally on your computer, or you can even run it in the cloud. And what this is about, so when we talk about multi-cloud infrastructure, I think this is currently business as usual. Yeah, we have the top 3 cloud providers as the quasi-standard in the cloud section. But what happens and what we observe is there is, let's say, a lot of demand and requirement for optimization, for cost effective, because if you look into, let's say, the monthly bills, you will see, oh, if I'm using this cloud provider, that is really, really expensive. So we observe there is a rise of third-party cost optimization tools, AI-based and so on. How can I manage, for example, my different cloud resources? And how can I cost optimize them? And the last thing is the sovereignty discussion. Yeah, if you look now into the latest news, you see that top 3 cloud providers are all offering, let's say, sovereign European offerings that are more or less cutted and customized for the European consumers, following European regulation standards. Yeah, and as I said before, there is the multi-provider cloud adoption. We see heavily the container as a service that is used by the developers. But we also see a day-by-day decision for data and service workload management. And what is even worse to our, let's say, experience is that there is no interoperability between the different cloud providers. Yeah? So if you are in one ecosystem, usually you stay in the ecosystem. If you want to leave or have a multi-provider approach, you want to, let's say, share between the different ecosystems, that is heavily related to efforts, migration, integration. You need a lot of resources. And even for the multi-region, multi-site integration, it is quite difficult. So the teams, and this is where we come from. So because we provided this software solution to enterprise teams, which have still the challenges because they have siloed solution offerings. They have a costly integration. There's a high effort using applications from the open source world, because usually when you are in the cloud ecosystem, you use the provided services from the cloud providers. And this service offerings from the cloud providers are getting so complex that you really need to have a lot of experts. And usually companies are sparse on specialists, experts, and these experts are also expensive. And let's say companies are not leveraging the potential of this multi-hybrid cloud. Edge cloud is coming up, and using the open source ecosystem. Yeah, that's why we came up with this Daiteap Cloud Console, which is in fact a user interface and a command line console for spinning up and operating cloud resources from top 3 cloud providers. Yeah, and we saw there is always a demand. This is not, let's say, the only one, but this is one of the main demands. Usually developers need a virtual machine, they need storage, and they need Kubernetes. Yeah, and this is where we come from, where we say, okay, for the productivity, we want to enable the developers with a kind of self-service where they can, let's say, spin up then virtual machines, where they can spin up their Kubernetes cluster, and have also a service catalog on top where they can then deploy their open source software exactly to the resource they are selecting. And this should be central interface to virtual machines, S3 buckets, and Kubernetes clusters. And you should keep track on it. Yeah. And the same is then that we are also worked and experienced in integrating edges or small devices like Raspberries and so on, where you can then have different kind of devices and resources integrated. And we see there is a a need or also a demand on the multi-site, multi-region, to connect and configure multi-site, multi-region infrastructure resources. I come later to some use case scenarios. And also for the multi-infrastructure as a service, always a topic is a fast setup, security and compliance, manage and monitor, and then the integration of IoT devices. And how do we see this currently? So usually, whether you have the on-prem, you have the public, you have the private, or you have the edge, no integration, you have a single cloud workload management, a redundant user management, and a high migration effort. And we don't see currently solutions for federated data and AI. There are, let's say, approaches to it, but there's not a kind of, let's say, a community standard how to do that. And usually you have a low data sovereignty if you go to the public clouds. So what we thought about, and this is our main focus of the Daiteap console project, is that we want to have a full integration. We would like to have also between the different infrastructures, the network integration, that we can, for example, have a higher degree of sovereignty. And we want to use the self-service experience between the premise, public, private, and the edge devices. And therefore, we put a kind of Kubernetes approach over it, where we span in all the different resources. And we are not only, let's say, spinning up a Kubernetes cluster on one provider, but we have a solution for spinning up a Kubernetes cluster across providers, which are connected with virtual private networks. And I can therefore use different, let's say, infrastructure service providers across the world to have as a commodity below my Kubernetes, who gives the infrastructure resources, but the Kubernetes on top spans across those and doesn't care if I'm, let's say, have my nodes on an Azure, on Google, AWS, Alibaba, and it doesn't care where they reside. If they reside in US, if they reside in Asia, or in Europe. So our approach is to span a Kubernetes cluster across multi-provider resources, across multi-sites and multi-regions. Now, that is the core focus. And what we then added additionally is a service catalog, where we can then deploy exactly the services to the different resources in this, let's say, internationalized Kubernetes cluster, where we then have a kind of self-service management, and I can exactly define which service runs on which node, in which country, in which region, on which site. And this is, for example, let's say what we have in mind well for distributed AI frameworks. So if you think about Kubeflow and you have data, for example, across the world, in your global company, and you want to use data for the training in Europe as well as in US, usually then you have this data sovereignty regulation issue. And in this case, you can span the Kubernetes cluster across these regions, and you can use your Kubeflow, for example, or your TensorFlow, and train the model with the data that reside on the region you prefer. So the use case scenarios that we see for the business benefit is that we can integrate these multi-site, multi-regions infrastructure as a service. We can leverage the open source ecosystem through the catalog. So we are not dependent only on the cloud providers ecosystem services. And we have a simplified self-service for application and service deployment. And in the end, we can do, for example, IoT machine learning, predictive maintenance, AI, federated AI learning. And there are many, many cases coming up at the moment where this approach helps and makes it easier then also for the people. So in the value creation, for example, the key benefits are you can lower the cost of migration. You have less staff time, faster time to development, increase the efficiency, So these are just examples. And on the other side, you have the multi-site management. You can keep track of the environments and the service deployments, integrate the open source services, customizable service catalog, and can even offer solutions for migration if you want to migrate from one cloud provider to the other cloud provider, and you have a Kubernetes cluster span over these two cloud providers. You can move out the data from one to the other without any problems. So as I said, this is on GitHub as an open source repository. Today, I would have also a demo, but unfortunately, my presenter today is for private reasons not available. So on short notice, we cannot show you the demo, but nevertheless, I have made some screenshots and walk you through how this then looks like. In any case, download it to your laptop, install it and use it on the local host and try it out, and you can get yourself an impression on the software. So what we offer is a command line interface, using the console APIs. So everything that you want to do, you can also automate via the command line. And this command line has the same functionalities as you also find in the UI. So if you want to do it software-based, you can use it via the APIs. If you want to use it via the user interface, you can sign in with your account, or you can use the social login from GitHub, from GitLab, from Google, to make it easy for the teams. And then you find here a kind of dashboard, an overview dashboard, where you can set up your project, create a Kubernetes cluster, create a virtual machine, set up the storage, and manage your credentials. And there is a kind of green line, as you see. So we guide you also through this whole process in order that you are ready to work with it. How do we organize it? So the top level organization is the projects. Everything is under a project. In this case, here is the IoT data project, that you can edit and add, for example, users, resources, and so on. And as you see here on the top, you can always add a new project. And to have more details of this project, you can see, okay, which resources am I using there? Kubernetes clusters, virtual machines, storage, which are all under this top-level organization of the project. And you can easily here add machines or clusters or S3 buckets to that project. And you can also have an overview of your different Kubernetes clusters and also have the operations. I can edit the Kubernetes cluster, I can add nodes, I can delete it, restart it, or I can save it as a template. So if you want to spin up always the same cluster that is, for example, used by your team, you don't need to configure it, but you just save the template in order then to spin it up again with the same configuration. And for sure, you can also download then the config. How does this multi-provider Kubernetes cluster look like? So usually you choose which provider you want to use. In this open source project, we have the three AWS, Azure, and the Google as the infrastructure providers. You add your cloud credentials, and you can then choose the different regions that you want to use. And to make it a bit easier, we have also pre-configured cluster sizes, S, M, L, and XL, that you don't need always to think about, okay, how many resources do I need? And it's also easier then for the cost optimization. So for example, if you choose the S, you have a control with 3 and 3 worker nodes, 24 CPU, 64 GB memory, and 200 storage. So these are pre-configured sizes from some experience we had, but for sure, you can also configure them in a different way. As well, then, if you want to see the cluster details, you can see Here an overview, yeah, also with the integrated Longhorn storage for this Kubernetes cluster, and also the different parameters. The same for the virtual machines. Yeah, you can choose, for example, Amazon Azure Cloud. You can set up your region for the same and spin up the virtual machine. For example, Amazon EU Central. Yeah, and in the end, you can save the same as with the Kubernetes clusters as a template. So every time you want to spin up a virtual machine, you don't need to go click it and search the flavor that you want, but you just have the template and it runs then automatically and gives you always the same configuration. Yeah, and the same approach also to the S3 buckets. So you choose your provider or multi-provider, you configure the parameters and the name, and you set up the S3 bucket storage on your provider of favor or on every three provider. You can also manage the different users. Yeah? You have, for example, you can edit them, you can delete them. So it's a very basic user management. And I think it fulfills the functionality for this project. And in the end, you can also manage and add cloud credentials for the different providers. So that you can have access for the different users. They can use their different cloud credentials. And you as an administrator can then also delete or add or check the status if the cloud credentials are still valid. In the end, and this is maybe the nice thing to have then on top, there is a catalog, yeah, that is created so that you can, for example, if you spin up infrastructure resource, or let's say this multi-region, multi-site Kubernetes cluster, you can deploy then on the node that you select. For example, from these open source tools, exactly choosing the right destination, and you can deploy it by 2 clicks without doing anything. Yeah, so we have a kind of Helm repository, but also in the latest version, there's the Kube apps integrated. So you can also choose from the Kube apps and deploy then on the node that you select. So this is a quick run through the project. Yeah, would be happy if you have questions. You can always contact me via email, and otherwise I would be happy if you find some benefit on it, or if you would like to contribute also to the open source or fork it.
Great. Thank you very much, Christian, for the presentation. Thanks. So now we can open the discussion section. If there are any questions, comments, ideas, things to share from the audience, then just unmute yourself and speak, or raise your hand, or you can also write it in the chat, and then we will read it out loud.
Now, I have a question, Christian. What kind of language have you used to program the solution?
Yeah, we have different. We have Go, but we have also Vue.js for the interface.
Mm-hmm.
Yeah.
Okay, because there is some part of the project that is very interesting for us, because not the part of Kubernetes specifically, but the virtual machines and the storage.
Mm-hmm.
Okay, we are developing also an orchestrator to do that. But the part of the connectivity with hyperscalers could be very, very interesting for us.
Mm-hmm.
And could be collaboration. We have developed the part of the private cloud in terms of the physical private cloud, the control of the private cloud in generic terms using OpenStack, and we are trying to focus in the next future what kind of connectivity with the hyperscaler could be implemented that you have experience in that. Okay, it'd be very, very interesting. It sounds very interesting, the project you have done.
Yeah, thanks a lot. Yeah, we developed also things in Go. Yeah, I mean, Go is a kind of language of the moment and very, let's say, efficient. Yeah. But I think the concept and so on can also transfer then maybe if you guys have a Java approach or C#. I'm not sure what you guys are working with, but I think that the concept itself and how we did it is transferable.
Yeah, one idea is that right now we are seeing in two approaches. One approach is to use the APIs of, for example, Amazon.
Yeah.
And the other approach is using, for example, Ansible or other automation languages to provide that kind of, for example, if you want to provide a virtual machine, you can use the APIs of Amazon, or you can use a playbook of Ansible. And we are experimenting in that two ways. And what way do you use really in your approach?
Yeah, there are. I know the Ansible playbook is an approach that is used. So we have a mix of own development. We use also Terraform heavily, and then use the APIs from the cloud provider. So if you want, we can exchange about this a bit in more details, and you can.
Could be interesting because. If you have used, for example, the Ansible approach is very, very simple to integrate in our workflow. It's very simple. You are using APIs is more difficult in terms of the code to integrate. But that sounds very, 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 very interesting.
Yeah, I would be happy if you drop me an email. And I can also then invite the developers, in order to discuss.
Okay.
Thank you. Are there any other questions or comments from the audience? Maybe just a question from my side, Christian. What have you planned in terms of the continuing developing or expanding this the solution that you presented? Is there anything in sight that would be interesting?
Yeah, we have discussions also with colleagues here from the ALASCA Association. Yeah, because currently for the Kubernetes operations we use a own developed approach, and we are looking also maybe integrating, or let's say there are discussions how can we utilize other ALASCA resources. For example, the colleagues from 𝗔𝗟𝗔𝗦𝗧𝗋 have a solution. Then the 𝗔𝗟𝗔𝗦𝗧𝗋 is always a solution in discussion. So we would, on this, let's say, Kubernetes spin-up layer, we would maybe also see how we can be a bit more efficient and utilize also existing software tools from the ALASCA to have maybe a broader and a more stable approach. Because one thing that we experience, it is really resource intensive always to let's say go after the latest versions, updating the Kubernetes versions and so on. The lifecycle management of this needs to be optimized, and therefore we are looking also to corporations and maybe using different tools for the whole organization.
Okay, great. Thanks for the answer. Jan has a question also.
Yeah, hello, Christian.
Hi.
Thank you for your talk. Here's Jan from Cloud and Heat. I have 3 questions. The first question is the compute VM virtual machine. Where do you spin up this? I couldn't see this in your picture.
On the cloud provider. So
is it spin up in?
So we are using the cloud provider's API. And then it is a virtual machine on the cloud provider resources. So if we want to spin up Google, we use the APIs from Google and spin it up in Google. That's why you need, let's say, the cloud credentials also to your providers.
Okay, and do you only support these official cloud or these hyperscalers like AWS, Azure, and GCP?
Yeah, we had also.
Or is there an option for having?
We have also had a project also with some of the colleagues where we use, for example, OpenStack as an underlying. And we had also, it's not public, but we had also, let's say, software for using OpenStack as an infrastructure below. Maybe this is also interesting to publish it. But there we were a bit in the discussion between Horizon, which comes with the OpenStack, and let's say our user interface, if there is not a overlap. But what I can imagine is, for example, if you want to integrate an OpenStack deployment with a public cloud provider, and then integrate it or abstract it via a Kubernetes cluster, could be one use case.
Okay, and is it possible to switch a workload from one cluster to another one?
Yeah, this is possible.
And with persistent, so if you have a workload which is calculating some stuff and you want to switch it from one cloud provider to the other, this is seamlessly going.
Yeah, good question. We didn't, let's say, had intensive experience in this use case, but we could figure it out. Yeah, I don't want to make too many promises. Yeah, that's why I'm a bit defensive here.
Okay, I see. Yeah, thank you. Thank you.
Listen, you have plans to connect with private clouds as OpenStack or VMware or other?
Yeah, with OpenStack, we made already experiences and had also a project. Yeah.
Okay, in that part, we have a lot of experience because we are working from probably 9 years, something like that, in OpenStack, and we have developed some part of the automation process only in OpenStack. Okay, we are not working in other environments, and in that part we can share some experience. Sure.
Yeah, that would be nice. Yeah, with OpenStack is always, let's say, the discussion. Yeah, is there still, let's say, the long-term benefit on OpenStack or not? I think no one can answer this question, isn't it?
Well, the idea is that we're working, for example, in the defense environment or government or banking, and they are big customers of OpenStack, big users of OpenStack. Okay, and in that terms, they are using traditionally 2 or 3 different clouds, but the internal cloud or the private cloud normally is based in OpenStack in the model.
Oh, interesting, yeah.
Great, thanks. Any other questions or comments? Doesn't seem to be the case. Otherwise, thank you once again, Christian, for your presentation and for everyone that's participated in the discussions. I think maybe there's potential to continue some of those after the Tech Talk. So thank you, everyone, for that.
Thanks.
Thanks, Maria, for having me, and thanks to the audience for the interest.
Thank you very much.
Thank you. I will just share my screen again to continue with the second part. Very briefly, some news and events that we would like to share with the rest of you. And again, I would like to extend also the opportunity to everyone to share anything that they want to share with the rest of the community. So let me first just mention, we also mentioned this in the last Tech Talk, but at the end of 2023, 2 new projects were accepted to the ALASCA Association. One of them is 𝗧𝗲𝗀𝗃, yet another Kubernetes. No, I'm sorry, I'm I'm missing out the last word. I don't know if anyone can help me. Yet another Kubernetes engine. Sorry, I was missing the word for the E. Which is a tool that supports companies that want to use Gardener in installing and managing Gardener in an easier way that usually you would need to have a lot of experience with Gardener, and so that's a very useful tool to support that process. That's one of them, and the other one is 𝗧𝗲𝗰𝗵, which is a workload orchestration management tool that can move workloads between different infrastructures. So those are the two new projects. You can find them online already on the ALASCA website. We are already posting some information on LinkedIn on those projects, and also calling for participants or anyone who wants to contribute to take a look at those projects and see if they want to use them or try them out or contribute to the development of them. So that's something that maybe some of you might want to take a look at. And then we would also like to mention a new ALASCA activity. This is also in line with what Christian was mentioning before. I think that there are some plans to work on a self-service platform for cloud resources that are based on the ALASCA technology stack. And in the next couple of days, we would like to set up a workshop to discuss how this might look like. So an initial concept for this platform. So if anyone wants to join, thinks they have an idea, want to contribute something, then please just contact Marius Feldman. I put his email here and let him know so that he can contact you also for finding this this slot for the first initial meeting. That's one point. Then another point is that we are planning an ALASCA Summit in the second half of 2024. So we will communicate quite soon the dates for that. So just you will find them on our website and our social media. So stay tuned to that. And we will also be asking for contributions in the form of presentations or workshops or other ideas for the summit. So maybe if you have any ideas, you can already start thinking about them, and then when we open this call, then you can share with us. We are very happy to see what ideas you have for this event. And then one last event I would like to mention. There's a save the date that has been sent out for the Sovereign Cloud Stack Summit in 2024, which will take place in Berlin. It's in May, 14th of May. So I also put here the link in case you want to take a look at that. Maybe that's interesting for some of you too. Then, just very briefly, we have almost first half of the year planned for the Tech Talks. So this is a brief overview so that you know what's coming up. In February, we have a presentation by Fraunhofer Institute. They will talk about Clouditor, which is an open source tool for the assurance of cloud services. Then on March 22nd, we have a talk from the project manager of AI Sprint from Politecnico di Milano, which is a research and development project where several open source tools were integrated, and he will provide an overview of that process and the results. On April, we will have a presentation by 𝗔𝗟𝗔𝗦𝗧𝗹𝗪, Dresden Internet Exchange and the Technical University of Dresden, and they will present this Internet Exchange and the impact that such local infrastructures have on us as a society, as companies, and so on. And finally, for May, we will have a presentation on the Infrastructure Manager, which is a Tosca-based cloud orchestration and deployment tool developed by the University of Valencia, Polytechnic University of Valencia, which also works together with some of the tools that we are now hosting in ALASCA, for example, 𝗧𝗲𝗃. So that's also a very good way of continue understanding how all these open source tools that are being developed within ALASCA, but also in the other the wider open source ecosystem in Europe can work together to improve the functionality of cloud infrastructures. So this is what's coming up. If you have any ideas for the future, then just drop us a line, let us know, and then we will plan those also. And if anyone has any other events or news that they want to share, then please do so. Now there's very open. Anything you think might be interesting, then just let us know. If you know of any events or if you have any news that you think would be relevant, then just let us know. Okay, then as always, just let me remind you that you can find all the tech talks on the ALASCA website. You can also send us an email at hello@alaska.cloud and let us know if you want to receive the invitations, or also send a message if you have any talks that you want to share with us that you would like to present. And then if you missed any of the tech talks in the past and want to take a look at those, then go to our YouTube channel and take a look at that. And otherwise, we will meet again on the 24th of February with the talk on the continuous assurance of cloud services tool 𝗧𝗲𝗰𝗵 by Fraunhofer, again at 11 a.m. here in Zoom, and we can continue the discussions. So that's all from my side. Again, thank you very much, Christian, for your presentations. Thank you to the rest of you who were here today for the discussion and for participating. And hope to see you in February again.